Now coming to the float data type. The float data type is having the same similar operations and also includes some extra operations which we perform in integer. And yeah, it supports all the operations that we have done so far on the integers. Like all these operators can be performed on float also. Suppose let us check this. Now I have taken a equal to 27.5, which is float. We can check the data type using type function. We will get as float only. Print of what we do, type function. Type of, let's check a float. Suppose let us check for 2.0. Even it is 2, we are keeping as 2.0, so it is considered as float only. Okay, now let's do operations which we have performed on this with the float also. See, let's do all together. Now you can see what we have done. We have just added it. 2.5 plus 7, 27.5, we get as 30, and it is also float data type. Output will be on the float data type only. What are the operations we perform with the float? Suppose if you perform an integer and a float also, the output will be always a float. Okay, not the point to remember is when you perform an integer and a float both together, also will get the same. Suppose if I am removing this and now b is a integer format, see, even though the output is in float only. Okay, now let us change it to again float. See, only the difference we are getting in the float division, because in float division we will divide it and we will just write the whatever the integer part is there, that we will write. Okay, that's why we are getting, when we do with the integer we are getting like that. Suppose let me change it like this and run it. See, when the numerator is a integer, we are not getting, but when we are dividing a float data type with the integer, we are getting the integer data type. Okay, that's the point to remember. And let's change it to float only. Yeah, see, the addition is performed well, and then subtraction is performed, and the ABS, what it will do, it will convert it to minus. Suppose if I give the b minus a also, you get the same 25. See, got it? Okay, now the multiplication is performed well, and division and float division. See, in float division, coming to the float division, you're getting this 1.25, we are getting it as 1.0, means 2.5. 2.5 is being removed. Whatever the extra values are there, that will be removed, and the only the decimal part along with the 0.0 will be returned. Okay, that's how the float division means how many times it is dividing. Float division gives the just the coefficient, right? This coefficient is 1 here. What is the integer part, that will be written. Okay, suppose now what is the b modulo a? B modulo a. B is 2.5. Modulus of a. A is greater, no? So it will get the whatever the b is the remainder. Okay. Suppose if I write a modulo b, what will get? 0, because it is completely divisible. But we are getting as 0 by 0. Okay. Okay. And some other functions are there to learn in float. Those are the round off function. What is this round off function will do means, suppose for a float data type, if the number of decimals is having greater than 5. Whatever the it is, if it is greater than or equal to 5, then it is going to round off to the next value and give the output. And this round off we can perform how many digits we want, we can do. Suppose let us check the example here. Let me take the example as I am taking 2.5. Okay, okay, 5 4 3. This is the example I have taken. Okay, I want to round off this one. Suppose let us print round off. We use round off function. What will be there in the round off function? The number. First one is first argument will be number. Number what will do? Let us give 2.543. Okay, and by default if you round off it will give it to the 3, means by default the round off value will be taken as 0. This is the number and we will have 0 like this. The same output will get because the default value is round off 0. The integral part will be given. Okay, now suppose I am giving print of a. Suppose we have a, I am giving a value as 0 1 3 4 5 6. Okay, 3 4 5 6. After here I have given. Now I want to round off to this, means after decimal point I should get 3. Let's check it. Okay, we didn't give round off function. Now see how many digits are there after decimal point? 3. So we can choose how many values we want after the decimal point. We can round off to that. This will be useful in the some of the cases like where we are getting lot of numbers, but to show perfectly and neatly we'll get to this one. Suppose here if it is 2, like it is getting 1 2 3 4, we are given up to 3 decimal points we are round off. Suppose if I change this value from 2 to 9, what will be the output? 5 point. What will be the output? 5 point means 27.502 will be the output. The next number will be the nearest number, right? The nearest number for the 9 is 2. After the 0 it will come to 2, right? Like it is, you consider it as 19, it comes to 20, right? Similar way. So this is how it is going to work. Suppose if I give 5 also, 4 it don't get any different, it will come to 1. Okay, 5 it will come to 2 only. So 5 and greater than 5 will be given to the next number, and that is why when you do the direct round off also it is going to, here what we have 2, right? Next number is what after 2? 3. So it is round off into 3. Suppose I am writing here 4, means what will be the output? Only 2. See, only 2 is the output. Okay, and what is the output for this? 27.502. Okay, right. And we also perform other operations in the float, but for that we need to import a library called math, which contains some mathematical operations. Okay, so we are going to import this one, and then we are going to use this. Now I am printing. In this math we are going to use cell. Seal means what will get, seal means it is going to, what it will do means this function is going to give the output of the decimal point to the next number. Like suppose if I give 2.59, if I round off, just simply if I give round off 2.59, what round off will do? Round off will give the 3, right? Suppose if I give 49, means round off will give the 2, means nearest value it is choosing, but seal is not like that. It is going to choose the next number only. Whatever the value you give, it is going to choose the next number. See the 2. Suppose if I give 5 9 also, it is going to select the 3 only. See, it is 3. Okay, now it is writing 3 for any value. Okay, this is how seal going to work. Now let us check another method called, we have to, while we are using the method which is imported from this library, we have to use that library dot, we have to use the method name. Method is what? Floor. Now what we do with the floor? Floor will do just simply do the cut off the decimal value and it gives the integer value, like just the how the floor division will do, it will just give the, like floor division is created in the form of function. You can thought, I can say that, like suppose I am giving 2.78, what floor will do? See, only 2. If I give 12.78 also, only 12. See, that's how it is going to. Okay, now, and this math library contains many other properties and functions which are like square root. We can perform different types of operations. Suppose, yeah, we forgot to do the squaring operation. Squaring is nothing but how we perform in the integer is like, see, let me perform here. Print a, let us take a star star 2, 25 square. 25 square, what is 25 square? 25 into 25. What did we output? 625. See, yeah, 625. Star star will give the power operator. This is the, what is the power we are going to give for this element. Okay, this is the base and this is the power. And similar way you can perform the power operator in this also. Okay, let's check. Print a star star, that is, let me give b. What will be the output? See, okay, let us make this simple, and I'm giving a square. See, 25 square, but this point is there, 2.5 and 2.5, 6.25. Okay, this is how we perform in the square operator also. Okay, yeah, these are the building methods that we perform on this float data type. Now coming to complex, which we will discuss in the next video.